Okay, ladies and gentlemen, so the next thing we're going over is factoring. Now, factoring is going to become very important when you get to pre-cal, and in fact, in every other math class that you have. So without further ado, let's get started. So this first type of factoring is for when your a, remember we were talking about quadratics, so our equation is going to be ax squared plus bx plus c. So when I refer to a, b, and c, these are the numbers that I'm talking about. So when your a is equal to 1 or negative 1, like we have in this case down here, we are simply going to ask ourselves, okay, what number can I multiply to get to my c, but add up to get to my b? In other words, the two numbers that I choose have to both multiply to my c and add up to my b. So for example, if we start thinking about what numbers multiply to negative 72, well, first of all, they have to be a negative and a positive, right? So we can start listing them out. We can say, okay, so negative 1 and positive 72, right? But if we add these together, they give us, well, that gives us 71, which is not 14, which is not what we're looking for. So we can have negative 2 and 36. And if we add these together, well, that gives us 34. So that's not it either. We can have negative 3 and 24. And again, if we add these together, this gives us 21. So these are all not it. However, our next one, if we take negative 4, and we multiply that times 18, well, we multiply that together, that definitely gives us negative 72. And if we add these together, well, that gives us positive 14, which is what we're looking for. So this checks out. Now we could write the other factors, you know, negative 6 and positive 12, but that would only get us to 6. And of course, there is negative 8 and 9, which if we add these together, that gives us positive 1. So these are definitely not it. So the numbers that we're looking for is negative 14 and positive 18. And so what do you do with those numbers? Well, actually, it's very, very simple. Once you find these numbers, that's how you factor. That is your factored equation. You're going to take x minus 4 times x plus 18. And there, you factored this out. Basically, you broke this down so that these are being multiplied. And if you were to use FOIL method, right, first, outer, inner, last, you would go ahead and find your original equation. So that's it. Now, what do you do if you have a negative in front? Well, you're basically going to do the same thing, except that this time, you need an extra step at the beginning. And this extra step is going to be to just factor out the negative. When I say factor out, I just mean divide everything by the negative, right? So I'm going to factor it out so I can get rid of it. So in other words, I'm going to put this negative outside of the parentheses like so. And everything is going to be divided by negative. In other words, I'm going to switch the sign of everything. So I'm going to have x squared. It's going to be minus 13x. This is going to be positive 12 now. Okay, so we're looking at this, and we're asking ourselves the same thing. Okay, what are the multiples, what are the factors of 12 that add up to negative 13? So the factors of 12 that add up to negative 13, well, let me think of the factors of positive 12. I have 1 and 12, right? And look at that. Those add up to positive 13. I have 2 and 6, and these add up to 8. And I have 3 and 4, and these add up to 7. So none of these give me my exact answer, right? Because I'm looking for negative 13. But if I were to turn this negative and this negative, well, then both of these would add up to negative 13. But a negative times a negative is still a positive, so that would add up to 12. So in fact, this will check out. So we're going to have the negative is still on the outside. Remember that. We have negative x minus 1, x minus 12. Alright, do y'all see that? So now that we did that, that's really all we have to do. This is all factored out. You can just write this as negative x minus 1 times x minus 12. Now in this next example, we no longer have an a, b, and a c, right? We are missing our c. We have an a and we have a b. That n just signifies another variable. It's just another x. You don't have to worry too much about that. But if we have something like this specifically, what we want to do is we want to go ahead and factor something out of this. Is this 6 and is this 9 divisible by the same thing? And the answer is yes. They are both actually divisible by 3. So if I wanted to go ahead and factor out a 3 before I do anything else, I'm just going to go ahead and take this whole thing divided by 3. When I do that, I'm going to go ahead and put my 3 on the outside like so. I'm going to take, okay, this right here is going to be 6 divided by 3. That gives me 2n squared plus, and that's going to go ahead and give me 3n, right? Okay, now that looks alright, but is there anything else that all of this is divisible by? I think n, right? If I went ahead and divided everything in here by n, that means I can put a 3n on the outside. And I'm going to go ahead and take this, and it's going to be 2n plus 3. You see how if I were to distribute this 3n in here, it would give me my original equation? That's what we're looking for. We're looking for everything to be able to go back to the way it was without having any trouble at all. So this is the most that you can factor this out. Alright, ladies and gentlemen, so we come to this problem that doesn't have any common factors that I can factor out right off the bat, right? This 11 is not divisible by 2, which is basically the only number that the other two have in common. So we can't really factor out anything. So what we're going to have to do is we're going to have to multiply a by c and basically do the same thing that we did on that last page. Right? We're going to find a number that multiplies to the sum of these numbers that is going to add up to 11. It's going to multiply to the product of these numbers that's going to add up to 11. So we're going to go ahead and take my a times my c, which gives me 2 times 12. That's going to give me 24. Alright, now that I have this number, you see where I got that from? 2 times 12, that gives me 24. Now that I have this number, I'm going to see what number can I multiply to 24 but add up to 11. So let's go ahead and give that a shot. I have 1 and 24. I have 2 and 12. What else do I have? I have 3 and 8. Oh, is that it? Yeah, it looks like that's it. So 3 and 8. These are both going to be positive, right? Because these positive 8 and positive 3 multiply to positive 24, and they add up to positive 11. So what we're going to do with these numbers, we're basically going to replace this 11 with these new numbers like so. We're going to write 2x squared plus 3x plus 8x plus 12. Do you see how I didn't really change my equation at all? If I were to go ahead and make this 3 and 8 combined, right? If I were to combine like terms, this 3 and this 8, I would still get 11. So these two equations are actually completely equal. They have not changed at all. But now we can go ahead and start factoring things out. In fact, it may be a little bit easier if you were to switch these, but you'll get the hang of it. as you go on. So basically you're going to look to this and you're saying, okay, what can I factor out of here? Right, you're going to basically separate it down the middle and you're just going to look at this side. Okay, what can I factor out of here? Well, if I were to say, what do these two have in common? Well, they just have x in common, so I'm going to go ahead and bring out this x, and I'm going to be left with 2x plus 3, right? And if I look at this guy over here, right, this side of the equation, well, what do these guys have in common that I can factor out? Well, I can probably factor out, let's say, a 4, right? And that leaves me with 2x plus 3. Take a look what happened. We have 2x plus 3 here and 2x plus 3 here. When both of these are equal, we can actually combine these. So this is going to be x, and since this is a positive 4, I'm just going to add these together. So this x comes down, this 4 comes down, and we're left with x plus 4. And these two, since they're completely equal, we're going to go ahead and just combine them together. 2x plus 3. And so this is your factored out equation, right? You went from this to this. So what we're doing now is we are factoring what we call a perfect square trinomial. So we have a perfect square trinomial here, and this is a difference of two squares. Now, the most important thing you have to notice about these two is that they have squares at the end. And I'll explain a little bit more about this guy in a bit. Let's focus on this guy for right now. So let's take a look at it. We notice that this whole equation, right, just the first term is 4x squared. That 4x squared is actually a perfect square. In other words, if I took the square root of it, it would give me a nice round number. This last term, this c, is also a perfect square, right? 36, the perfect square of 6. 6 times 6 is 36. So now that we have this, we can actually basically, instead of going through this whole mess that we went through in the problem right before it, we actually have a sort of shortcut. And this shortcut depends on two things. So the first thing is going to be for both the first term and the last term to be perfect squares. So the other thing that it's going to depend on is that once you take the perfect square of your a and of your c, so I'm going to take the perfect square of my a and the perfect square of my c, that's going to give me 2, and that's going to give me 6, right? Once I take these two perfect squares and I multiply them together, 2 times 6 is equal to 12. I have to check whether this number is half of my b. And I'm not talking about that minus b, right? I'm just talking about that right there. So since it is, right, if I multiply this times 2, that would give me 24. This all checks out. So because this all checks out, we are going to actually just have this. We're going to take the square of this, which gives me 2 x, right? If I were to take the square root of 4x squared, that just gives me 2x. And then if I take the square root of 36, that gives me 6, right? So I'm going to have 6 right here. Since this was positive, but this was negative, we're going to bring down that negative, and we are done. See how simple that was? All we did was we took the square roots of this, of the first term and the last term. We checked out if when multiplied, they added to that equation. And yes, they did. And then we just brought down the negative because that one was negative. And we just put the square root of the first term, the square root of the last term, and we're just squaring both of them. Easy peasy. I know this might be a little bit weird to see right off the bat, but always check if your first term and your last term are perfect squares, and you should be able to figure it out from there. Now, if you don't believe me, which I know some of you are like, what? We can go ahead and multiply these guys out. See if they actually do what Becerra said they're going to do, or if Becerra is going crazy. So if we take 2x times 2x, what does this give me? This gives me 4x squared. 2x times negative 6, that gives me negative 12x. And 2x times negative 6, that gives me another negative 12x. And negative 6 times negative 6, that gives me 36. So if I combine like terms, what does that give me? 4x squared minus 24x plus 36. You see that? It's the same exact value. Awesome. And this is called factoring perfect square trinomials. Okay, a difference of two squares. Now, remember, difference means subtraction, so this is only going to work when you're subtracting two different squares. What do I mean by squares? I mean that this first term is a perfect square, and this last term is a perfect square. In fact, we're going to go ahead and simplify it by taking the square root of this and taking the square root of that. The square root of 25x squared is just 5x, right? We're going to put this in parentheses and we're going to just square it. Why? So that I don't change anything, right? I haven't changed my value of anything in my first term. I'm just changing the way it looks. That negative I'm just going to bring down. And once again, this 49, I'm going to take the square root and I'm going to put a squared because I'm not changing the value, right? I'm not minus 7. I'm not doing minus 7. I'm subtracting 49. I'm just changing the way it looks. Now, once we have it to this point, it actually becomes very, very simple to factor. This is just a pattern that you're always going to follow. You're going to take the first term that you have, right? You're going to take 5x, and you're going to go ahead and add that 7, and you're going to multiply it by that 5x, but now you're going to subtract the 7. This is always going to be true. Whenever you have a perfect square here, perfect square there, and you're subtracting, you're just going to go ahead and add the two square roots and then subtract the two square roots of your terms. Don't believe me? Let's go ahead and try this out. If I wanted to multiply 5x, I wanted to multiply it by 7 and take 5x and multiply it. Let's see here. I would get 5x times 5x, that gives me 25x squared. 5x times positive 7, that gives me 35x. 5x times negative 7, that gives me negative 35x. And negative 7 times positive 7, that gives me negative 49. So this 35x and this negative 35x are going to cancel out, and I'm left with 25x squared minus 49. You see, it all added up.